Let capital A denote the event of placing a $1 straight bet on a certain lottery and winning. Suppose that for this particular lottery, there are 3,087 different ways that you can select the 4 digits, with repetition allowed in this lottery, and only one of those 4-digit numbers will be the winner. What is the value of the probability of that event? And then what is the probability of the complement of that event? So let's go ahead and take a look at that. So again, our answer is we want to find out what is the value of the probability of event A. So recall that if a procedure has n different simple events that are equally likely, and if an event A can occur in s different ways, then we would say that the probability of event A is the number of ways A can occur over the number of different simple events, which is s over n. So in our problem, we know that the value of s is 1, because that's placing the $1 bet, and the value of n is going to be 3,087. So what we want to do is we want to calculate the probability of event A, and we want to divide to find the probability. So in this case here, what happens is if we take the probability of 1 divided by 3,087, so if we take 1, divide that by 3,087, then we get the following number. This is a scientific notation number where we see 3.2393909994, and this is the same thing as times 10 to the negative 4, which means we need to move this decimal place over to the left 4 times. If we move it over 4 times, we get 0.000323939. And in this problem, they want us to then round that to 5 decimal places. So we get 0.00032. So let's take a look at the result. So the probability of event A is 0.00032, rounded to 5 decimal places. Now we need to find out what is the value of the probability of the complement of A. So to find the complement of event A, we denote that with a line over the capital A, and it consists of all the outcomes in which event A does not occur. And note that the probability of the complement of A can be found by subtracting probability of event A from 1. So we're going to calculate the complement and then subtract to find the answer. So again, the probability of the complement of event A is equal to 1 minus the probability of event A. Well, from the beginning from up here, at the last step of our problem, we found that the probability of event A is 0.00032. So if we take 1 and subtract that value, then we get 0.99968. So let's go ahead and do that. If we take 1 and then subtract 0.00032, and we get 0.99968. And therefore, the complement then rounded to 5 decimal places is that following answer.